Good morning, Brian.
Hey guys, sorry I'm a little bit late. I was muted and talking into a muted mic. All right, yeah, let's go ahead and get started here. I've been super busy lately, but I got around to cutting up that table that we mentioned last time around the PMR. And so I think the general idea is try and provide some sort of description that at least covers each instruction in some way, right? So that people get a little more of an idea. And trying to going through each of the example commands here. Um, I'm I honestly don't know. I don't have enough context on I think a good number of these to know exactly how they're used. So I think I'm going to need a lot of help, adding flavor text here. So we can go through the call today, but Ram, if you remember some of the legacy behind some of these two, that would be good if you can also add like offline comments and stuff. But we can try and get through what we can during the meeting.
Will do, Brian. But I
So,
can definitely talk about the NOP. So BAPI took most of these from my original implementation in my previous company.
uh-huh.
And there I had a need for NOP because NOP was basically their entire PMR was 0. And I was using the few bits of the command to actually generate an interrupt to the software to say something is available in the PMR. And that was the reason why I needed an encoding of all zeros to say there is nothing available to do. And that was more like indication that not to generate an interrupt to the software because there is no new command available. I believe now, I think I don't know if NOP is still all zeros. I think looks like it
It
is.
is not. It is not. The stage is general, which is 111.
Right. So I'm not sure how or if there is a need for an NOP. Um, or if there is a different way we can indicate that there is something in the PMR that needs software attention and software has to come and do it. So the original motive was basically to let the software know, and I don't think we are required to send. I mean, there is no need for sending NOP as a command over the sideband because sideband is already very slow. So we don't want to send anything that means nothing.
Okay. Is it useful for testing or anything like that? I mean, is there any other reason to have this other than the eccentricities of your particular software implementation that you had?
Um, Nothing comes to mind. Paul, do you feel there is anything that in your implementation that may require an NOP?
No, not at all.
So should we remove it?
Yeah, I mean, because I mean, this implementation is, I would probably say, 1,000 times more elaborate than what I originally had. So yeah, I think if there is no longer a need, I'm okay with letting it go. I think the only thing is if we remove it, I don't know if we have to provide any guidance to the implementers to say how to interrupt the local side to tell the software on the local side that there is something in the PMR that software needs to take action. I mean, there are multiple ways to do that. So yeah, I'm okay with removing NOP.
I guess I'm a little confused on what you mean by interrupting local software to take action. I mean, when you write a message into the PMR, shouldn't the implementation notify software there's a
Right,
message?
you could do it that way too. So a write to the PMR, you can detect that a PMR got written, and you could actually use that indication to also send an interrupt. It's just that the way we had all our internal CSRs and everything set up, it was easier to just or a few bits of the register itself to generate the interrupt. So that's the choice that I made.
I
But
see what you're saying.
yes,
Okay.
I think it is all implementation dependent on how they want to let the software know that there is something available in PMR. I think that portion can be left as an implementation choice.
Okay. All right. I'm just going to say remove for now, and we'll have the option to add it back in later because the bits are there. All right. So, all right. Link ready. I think that one's pretty obvious. Do we need any additional flavor? Because I think you just, whenever you're ready to transition into OPN, you issue link ready, and then that's it, right? I mean, there's something else there, right?
No, I think it's just basically to say um, each side is ready. So each side exchanges their own link ready to say they're ready. Again, I didn't have this in my implementation because once the link is ready, I directly use the main band. I have a few bits in the main band that pass link specific information between the two. So I used the main band itself. But yeah, I mean, if you want to do it on the sideband, we can do it here too. What is not clear is this link ready. I don't know if this is the main band link ready or does it refer to the sideband as ready. So that's something that's not clear to me. So
This is okay. All right. Well, I can answer that one because I've added all sorts of flavor text to the document. This is all of these statements are about main band,
main band, okay,
main band only, and main band in only one direction as well, right?
right.
So
Yeah, main band and only one direction. So the both sides need to come in and say they're ready. And for me, I wanted that indication to say my data link layer is up. And once we reach this stage, the exchange directly happens on the main band bits itself. So I did not need this additional link ready indication.
I see. Okay. Well, actually, I have a let's see. General. So you're transitioning from wait, what is the okay, let me look at the order again. This is a kind of a did I miss? Oh, here it is. Operational is the last one. So shouldn't this be in the IBU? Sorry, state, because you only ever transition from, you're supposed to do these linearly, right?
Right.
And so you go from IBU to to operational, but but currently link ready is in the quote unquote general, I guess, which can be in any state. So is the idea you could skip directly to operational?
I don't think so. I think most implementations out there, I think if they probably have to go through all the steps. I don't know if there are implementations where people store the
I think we explicitly say you can't say initialization. The document assumes but does not mandate that link is executed. No, wait, there was something about order with each stage. Yeah, okay.
well, it was the
While not
second.
mandatory, is the expected
Yeah.
link bring up will proceed through the stages in the order listed in table 13. I guess so. Since we don't mandate it, I guess that's why it's in general.
Right.
Okay. All right. I'll just add a note there then.
While we're on that table, do we introduce the stage encoding?
Yeah, it is. It's I might need to I might replicate it because it's kind of hard to read since it's in separate places, but it's up here in this table.
Oh, well, maybe we can just add this column and add it to the table 13, 12.
So I was thinking about adding it here because we talked about stages here, and it's also kind of relevant there when you're because that you use sorry, you're using these codes to build all of the ones in here, right? So
That's right. That's where it is used. It is introduced in table 20, that encoding, but then the description of stages are in table 12.
okay,
Yeah.
yeah, so
Yeah,
add them up
13,
here
yeah.
too. Yeah, I can add them up here too. That's fine.
Yeah. Or maybe just here.
Uh I don't see a problem having it on both places.
That's fine. Yeah.
Since we do talk about the values
Sure.
and the rest of it, yeah. Okay. Oh wait, what did I?
Actually, I'm not a big fan of having in two places. So how about in the text below table 13, we say that the encoding will be in table 15.
Yeah, it's also, oh, I just noticed it's in 15 and in 20. Okay. You think we should remove them?
I think in one place would be good, but then in table 13, the text after that, we can just say the encoding will be in table 20.
Oh, I see. Okay. Okay. So leave them in 20 and leave them in what was that up there? 13? 13. And then in this one, reference table 20.
Yes, in 15 reference table 20, and in 13 also reference table 20.
Okay,
Because
all right.
that's a, yeah, we'll diverge, and then it would be good to only update one place.
Yeah. Yeah, I actually, when reading through these, I just screenshotted that table and then had it off to the side when when reading these things from my in this. But I'm going to go through and add little text that says how these things are grouped. Say that's the stage and stuff, so it's a little easier to read down here too. All right, wait. So what were we talking about right before that? It was Ram, do you remember what you were saying right before that?
We were talking about the link ready and why it was in the open, or in the general category.
Oh, right. Okay. Yeah. Okay. Okay. Yeah. So we can note this instruction. ID. I'll fix these typos. Anyway, okay. All right. Let's move on to reset. So I'm a little unclear because again, reset is a general instruction. When are you resetting the link? Is this on an error? And if you get like an error packet or something like that, you might reset the link. No, that's side. If you get a PMR error instruction, is that something you would do as part of that flow?
It could be error. It could also be that error is one of the cases where you start dropping too many packets because of CRC or because of FEC and whatnot. So that is one use case where you will probably have to reset your interface. The other use case is maybe the software itself is requesting for a reset for its functionality. Maybe it wants to flush everything out of flush all the data out, so it's requesting it. And then the third scenario could be that there is a sudden change in the temperature, and the temperature sensors are triggering some recovery mechanism that could also cause the link to be retrained. So I think there are multiple cases where this could happen.
Okay, but does this change your link your link stage state? Do you
So
do you go back to EST or?
right. So I think the main motivation here is basically to let the other side know that the current side is going through the reset, and sending a PMR basically tells the other side that other side also needs to train the link from, because it's basically going to happen from both directions. So I think one use case is once. Again, this is implementation specific. So I had a data link layer state machine that would track all of these. But in the absence of a data link FSM, if one side goes down, the only way to let the other side know that, okay, I'm going to start my training again is via the PMR, because the PMR is expected to stay on all the time.
Okay. All right. So, but okay. Yeah. So it's implementation dependent. So we're not mandating any kind of stage change during a reset.
I mean, state change for which one, main band or side band?
This is all main band. This is so my expectation is any message that's sent through PMR, which is what we're discussing, is main band and main band only.
Right.
Anything that happens on sideband just happens in the sideband protocol layer. This is
Correct.
all link.
This is
So
all link, correct. So
yeah. So the question is if I send this command, like say I see a temperature change, right? And I'm like, okay, you know what? We need to do a reset. And I send a reset. The expectation from the other side is they act that and then send a reset back, right? And so
I
you
mean,
reset both sides of the link at the same time, right?
They don't necessarily have to send a reset back. Because the site that is requesting a reset is already going through the reset, right? So that side only needs an ACK. I think the only time where both sides would be sending the reset is when both sides detect an error at approximately the same time, and both sides software is requesting a reset. I think that is probably the only time when you would see the reset request go from both directions. Other than that, for
What is okay? Then maybe I'm confused. What does reset mean in this case?
the reset means, at least in my original terminology, it meant that we need to start the link training again, the main band link training again.
But okay, you're starting a link, but you can't link train without both sides knowing you're going into a link train.
Correct. And that is why we had this command go through. So it could go through just from one side to the other, and then both sides enter the reset state. Or it could be coming in from both sides if both sides detect the issue approximately at the same time.
Okay, all right.
Yeah.
Let me count. So okay, so either side can request. And ACK means you are moving into reset. Moving into training. Okay, all right. But what does a training state mean in this case? Are we actually changing the stage of the link bring up at that point? Because we don't really have like a state machine, right? That we are agreed on.
Yeah.
Right?
So if you go to that list of states, right? So it will reset everything to the very first step. You had that bunch of where you have operational state and whatnot, right? Yeah.
Yep.
So you'll probably go into the establishment state.
Okay, but okay, so that means something in our document. So this transitions the link into back into EST.
Yeah, you could put it that way. Yes.
Okay. Okay, and this because it's general, it can happen at any time. So it can actually happen during one of your other states, right? So if I'm in IBU and I sense this, IBUs are bad, is probably it's probably a bad example since it's like, you know, undefined kind of at the moment, but you could be doing some other bring up stuff and be sending messages back and forth in the main band for IB and as part of IBU, and then notice this and then go back to EST, right? You don't have to be in operational.
You cannot send anything on main band until you're operational.
Okay.
But you can potentially get a request in between, say, software was doing something else at some other portion of the chip, and that required a reset. It is highly unlikely that would happen, but you never know what can happen in the field, right? So yeah, you can potentially get this in any state if there are some other higher level operations that trigger system wide reset. But I don't know if we have to mention this in this spec, because that is, if a reset comes in between the establishment and operation, something else outside of the link has already gone wrong. So I'm not sure if we should detail.
Well, okay, so the reason I'm saying this is, again, we don't have a state machine. And so, but we're issuing, besides this like potentially linear set of stages that we're going through, right? And so we are having commands that potentially change the stage or the state of the main band, right? So I'm for things that change the stage, I've been trying to document when that can happen legally in the flow. So that's the only reason I say that.
Okay.
I'm trying to be not too constraining while also not being too vague.
Yeah, I agree. So that's a tough choice, right? So
Yeah. Okay. So all right. So with that in mind, if you're moving back to EST, then I have a question about the command itself, because you have the ability to do a reset for the link, and you have ability to do a reset for individual slices. And my impression is that the main band, everything is together, right? So would you end up being under what condition would you be where you're like, you know what, I only want to reset one slice?
yeah, so that for me also it was only link, but I think there were some implementation. Maybe Paul can also chime in, but there were some implementations where you could have a link that is formed out of multiple slices, and each slice could carry data independent of the other slice. So there were some implementations that wanted support for that, and I think that is the whole reason why two separate resets, one for link and one for slice, got introduced. But
Okay, so we should probably say that. So if you, sorry. Let's say, how do we want to read this? If you reset a set of sub slices in a link, the link stage may change, but this may indicate, let's say, training can be skipped on the unreset slices, possibly. Does that make sense? I'm not even sure how, I'm not sure how you would use that. Can you guys hear me?
yes, I'm reading through it. For a second. Yeah, I think that sounds okay. I think that is still again implementation dependent, because I mean, if they're using the whole thing as a single link, then they may not be able to use the subset of the slice that is still active anyways. But again, it is system dependent. Paul, do you have a use case where you have multiple slices and each slice is independent of the other?
Yeah, we do.
So you treat each slice then as a link, or do you combine a group of slices to say they all form one single link?
Yeah, so it's possible for, a given slice or group of slices to act as a link, whereas that's not the entire size of the phi. Like we have multiple links in a phi.
But we don't classify a link in the document as a phi. Yeah, it's a set of slices, right? These are logical entities, not physical necessarily. I think, well, let's go back and see how we classify, how we define link. How do actually, that's a question. How does the BOW spec define link? Wait, where's my assumptions and definitions? Link, a
Right,
universal
but
set of pairs.
yeah,
Yeah,
so
we don't say which slices they are. We just say it's a group of slices.
right. So we definitely need to, like, I guess, understand this, right? But to Ram's, question is, we have multiple link layers for a given, like, set of phi, get a set of slices, right? We implement, like, let's say we have an 8 slice phi, right? One monolithic, talking physical stuff, right? We have one physical set of 8 slices that implement a single phi. There can be multiple link layers behind that single phi. And so we would want to be able to reset, different numbers, one group of those 8 slices independently of the second group of those slices.
Right. So I think
But that's not the, I don't think that's the question. I think the question is if you have a link, whatever we're defining as a link, which is a set of slices, would you want to reset a slice within a link? Paul?
Well, I'm not sure your definition of link like meets that, right? I mean, that link definition that's in there looks physical to me.
Unidirectional set of pairs.
I mean, it's a connection between chiplets, set of wires, right? Now, I'm again maybe want to change that, right? But I'm just saying that looks more physical than logical to me, or certainly could be interpreted that way.
So I mean, we have this thing called you're assigning slices to a link, links between devices. I mean, it's physical, but you're just saying there's a certain number of slices in the link.
No, I understand. I'm just saying this could be interpreted either the way you're defining it or the way I'm defining it, equally well.
Okay.
I'm not saying one is right or wrong. I'm just saying my reading of this leads it to be
So
ambiguous.
I guess we need to rethink about this in terms of the spec that it initially goes into, or eventually goes into, right? So it's just going into the TLL spec, right? Which is a single bus of some sort going across a main band, right? Like you would not have, I mean, would you say that the link that's defined in the current translation and link layer spec is dealing with something that would define link the same way, I guess?
Right. Yeah. So I mean, that's the crux of the question, right? Does this link correspond to a TLL link?
Here, I'll pull the TLL up real quick.
Because my reading of this says it doesn't have to. I mean, it could, but it doesn't have to. Right? There's no verbiage that says yes, this corresponds to, a single TLL.
The logical connection between the link layers on two chiplets consisting of a number of near side transmit slices and an equal number of far side receive slices plus the same or a different number on the far side teak slices plus and an equal number of near side slices. They do kind of have a different definition because they do talk about it being bidirectional because I guess in this spec it has the connotation of a buses and everything requires buses back. And then I think the definition I have in the BOW in that one, I think that one in the other spec aligns more with the BOW spec because you can have unidirectional links. Though we might end up potentially editing this definition of link when we integrate here. And I also realize we're missing a lot of definitions here. Maybe we could fix that. Anyway, all right, let's ignore what the text is there. Let's decide what we actually want it to be. What do we want to define link as, and how do we want to define, and would we, and I guess again, if we define the link as a set of slices, right? Like and when I can say, I can add text saying the link is an arbitrarily defined set of slices, based on the implementation constraints. Would you need to be able to reset slices within a link?
I think, I mean, to Paul's point, right, I think the way we have described a link in our document, what we are referring to is a pathway between two chiplets. But then there is also this logical link or data link, like I called it in my implementation, where you could be using a subset of slices to form one data link. So when you do a reset, or when you want to do a retraining of the slices, at the minimum, all the slices that form a logical link or a data link, I think they need to go through the establishment phase together. So you don't have to reset everything that is between two chiplets, but you
I
can
see what you're saying. I see
do
what you're
a
saying.
subset. But it again depends on how you logically group the slices to pass a set of data between the two chiplets. Brian, did you stop sharing? I can't see.
I did. So because I shared the other document. Let me share again. Sorry, I was just thinking. Okay, all right. That sounds fine. Because we're basically saying that depending on the implementation, you may actually define link differently. It's not even a spec thing because people may want to have the flexibility of resetting a broader number of slices than what we're actually talking about when we talk about links here. So that's fine. So, but the question then still okay.
Maybe
So the question of stages then still there, right? So then from our specs point of view, if I do a reset on a slice within a link, the link still changes state, right? You still need to pause traffic across all of the slices in that link. And then maybe you only do training on one of the slices, but you still go through the stages again, right?
That's where I mean, it depends on how you're logically grouping it, right? So say for example, you have four slices between two chiplets. From a link definition per this document, you call that entire four slices as a link. But then you could also have a data link layer running on top of this, where the data link layer is only using two slices each. So you have two sets of data link layer per se. So in that case, if say something goes bad on one of the five, you only have to reset the slices that file belongs to, and the slices that belong to the data link a group of files over which the data is transmitted. So the other data link can still be active and be transmitting. So you only reset a part of the link and not the whole thing. So I think that's where
that sounds very that. I mean, if we want to do that, that's fine. I don't know. I feel really wishy-washy about how we're defining. I mean, what's the point of stages if it's that loose, I guess is the point, you know? Okay. Let me think about this for a sec. How about, do we want to say that, I don't know if we need additional terminology here then, right? I guess that's what I'm trying to get to. Something is changing state, right? But basically, based on what Ram, you said, it could be any combination of things in this mix, right? That are wholly independent, wholly implementation dependent, right? I'm not sure how I would even get consensus with someone I'm talking to and trying to incorporate these things to make sure that we're following the same definitions on what's actually getting reset if it's so loose. So it seems like we need additional terminology here to make it a little clearer. Should I call these logical links versus physical links?
Yeah, I think I was wondering, I mean, just for the reset 5tx slice k, maybe we can just add an additional note that the only time that would be needed over the resetting the entire link would be if subset of slices are used, when the subset of slices are used to transmit or group logically together to transmit data. I think maybe if you can just put that note, I think that should probably suffice.
Well, again, the question is what's transitioning in that case? So again, I think what we're really talking about here and what would make it appropriate here when we're talking about the things that we're dealing with here is a logical link, right? Which you said is not necessary. It could be any grouping of slices, right? But we are how about this? Okay. How about do we want to say that each slice maintains its own state? Does that make sense? Or we could say if sub slices are being reset, then each slice maintains its own state for the purposes of bring up stages. But the whole link is not available until all slices within that link are available.
Right, but then that is still not entirely true if your logical link is different from your physical link definition, right? So if your logical link is say you're grouping two slices together to form a logical link, but then the link based on the definition here is all four slices from the link.
Yeah.
So
okay, so again, so basically, at the end of the day, these states are only pertain to slices from that definition.
correct. That's what
Okay.
I think. But yeah, I think others may
Okay, I think we just need to add some text around that. I think that's fine. But then some of the terminology is a little fuzzy, but it's this weird right here. I'll just add a note right here and then think about it some more. Let me just so say that for now, and then we can revisit it. All right, let's move on. So this one, I think we're clear on. We had a lot of discussion before. We're just going to skip that for now. All right, let's move on to here. So this is also in general, and we're talking about, let's see, we have a full calibration required and disable training pattern. So what I don't know what either one of those really mean. This is just,
yeah, the full calib request
that's
probably
just a bunch of zeros. What is that? It's like almost a no-op. Oh, wait, no, there is, no, the secondary is one. Never mind. Take the back. Sorry, go on.
yeah, I'm trying to recall what.
Let's go back up to the message construction real quick. So this is general and it's one. No, sorry. General one right here. That's disable. Calibration request. That should, oh, I see. Primary is one, secondary is zero for a calibration request. So what is a calibration request? primary is one. I was misreading that. That's annoying. Primary is 1, secondary is 0. Okay, yeah, that makes sense. So full calibration, and then they have the 1 is disable training pattern.
Yeah, I'm trying to recall what the disable training pattern does. I'm kind of drawing a blank here. It's been a
Let's
while.
talk about the first one. What does calibration required mean?
Right, so the full calibration required probably is and the reset would probably do the same thing. So I'm trying to recall why did we add 2 of them, one for reset and one for full calib request. Paul, do you recall?
Sorry, no, this is before my time.
Okay. Yeah, because if you do a reset and you move back to the establishment state, then you are by default doing a full calibration anyways. So I don't know if there is a case where you can start calibration without moving to the establishment state. I don't think the way we have defined the spec today, I don't think there is a way to do that. If you reset, you will do the full calibration anyways.
Okay. Well, why don't you think about it offline?
Yeah, can you assign a comment to me here?
Yeah, I will try. I'll have to upload and then do the Google thing.
This is a docx version.
Yeah,
Okay.
this is still Word right now because of all the stuff. But I'm going to upload anyway, probably after this call. But I just, then I have to tag you, and then the tag goes away. Yada yada. Anyway, so on the disable training, why would we want to disable training?
Yeah, that one I'm completely drawing a blank. I don't know.
Okay. All right, let's move on then real quick. All right, so now we're moving on to slice bring up. So we have a ready to train offset pattern, and then I training pattern. Okay, so I think the second, I think these are all obvious, right? Is there anything we need to discuss?
These are all related to the training pattern that we want. I believe the disabled training pattern is basically to say that you're done and you can stop transmitting that. I think that is probably what that disabled training pattern means. Is once your RX calibration is done, just let the transmitter on the other side know that it can stop transmitting it. But maybe it is not needed because we are already sharing that information in other form. So yeah, I don't think that would be needed anymore. But yeah, let's keep it for the time being, and maybe we can just
think about it. Okay, but okay. So what about ready to train? Right? How does?
Right, so the ready to train is required because the way BOW training is set up, the TX side gets calibrated on its own accord. So that the TX calibration does not need anything from the partner to do the TX calibration. So when each side has completed the TX calibration, it has to go and send an indication to the other side saying, okay, my TX is done. So if you are ready, you can begin your RX calibration. So that's the reason why we need this ready to train indication from each side to go to the other side so that the other side can start RX calibration.
Okay. So let me get this straight. So we move into SBU, right? The RX side just goes into a wait state, waiting for the TX side to do its side.
Right.
The TX side then sends a PMR saying, I'm done calibrating the TX side, you can go. And RX side then goes, okay, and starts loading patterns into the TX so we can do the RX training.
Correct.
Okay. All right, that makes sense. But I got, let's see, wait a minute. I think we've, just from a coherency point of view, how do you move from, you start an EST and you go to SBU, how do you move to SBU? What command does that? Is there a command that does that, or is that implicit?
I don't think there is a fixed command for that, right? I think once you send the partner TX slice ready, I think you automatically move. I'm not sure if because like you said, right, there is nothing in here that maintains the states. All the states are maintained at a software level.
So
So
link ready transitions into operational.
yeah, but that operational state is basically, I don't know where it is maintained. Is it maintained as a software state machine or
That's so we're supposed to here, let's go back up to the stages.
yeah, I'm
So
saying,
based on the text here, you're supposed to start an EST and then move down the list, and you may skip things if you want, right? So you say you don't have an IBU for whatever you're oh yeah, again, if you're not doing the normal our link layer, maybe you don't have a credits. So you're not going through you skip IBU, but you do these linearly, right?
right.
So there has to be something that once you're an establishment moves you to slice bring up both ends of the pattern. Configure that component. And again, maybe maybe you immediately move into SBU once powered, or we can say make sure it's not mentioned here. Reset link. So we don't have any, there's no 000 stage here. So we don't actually have any commands in the establishment stage. TX slices ready to train. That the one is the command we were just looking at. Yeah, it was the command we were just looking at. All right, so here I'll just say this. Moves from EST to SBU when done with local initialization. And then this moves the RX side into SBU, right? Does that make sense? Sorry, I need to make sure that I'm talking about this. This is the ready to train. Does that make sense? You have to send, so the TX side, when it comes up, whenever it feels like it, it moves, it goes ahead, moves after EST, it can move into SBU, right? Because there's no requirement of steady state on both sides to move from EST to SBU, right? Because it's just power on. And then but the receive side moves into SBU once it gets a ready to train from, ready to train from the TX side.
No, so I'm trying to recall. SBU is sideband up. Is that what it
Slice
means?
bring up.
Oh, there's slice bring up. Okay, slice bring up.
So the first stage is establishment. Second is slice bring up, then link bring up, then interface bring up, then operational.
Okay, yeah, I think this sounds fair.
Okay. Okay, and then the other ones seem straightforward. So basically you're just changing training modes. And then this is the one we talked about last time, and I want to make sure. So I think we're missing a secondary command I need to add, so which might shift everything, but I want to make sure with you, Paul, that I added commands for doing upper and lower bit tests. I want to make sure this makes sense to you. And this is one of you. Because we couldn't, because you guys were talking about doing 32-bit patterns.
Yeah, so that looks fine to me, right? We basically just need the ability to just send 32 bits across at a time. And so we just need to duplicate each guy. And so it seems like you've done that.
All right, so I need to go back and add another code here because I think the where was the codes again, real quick. Just scroll past it. Yeah, we just have one. So yeah, I'll need to add the code then. All right, moving on. All right, let's see. Run a 16-bit test, run a PRBS test. Wait, so I'll probably have to make this run a pattern instead of saying 16-bit, since we're potentially supporting 32-bit patterns, just run a pattern test and not explicitly call out the number of bits, or like, because I guess what happens if you only load 16 bits and you don't load all 32? Do we implicitly, if your uppers are all 0, I guess you can implicitly just not run that. Okay, we can leave that.
Well, didn't we define a slice as 16 bits, or are we defining?
This is bits per. This is
the
pattern
link
bits.
to the PR. This is the
Oh,
link
this
to
is
the
individual
LFSR.
bits. Yeah, individual bits. So yeah, this could go all the way up to 31 because we are supporting PR. So the spec mandates 9 and 31 at the minimum. So I think that should be 31 bits at the minimum. If this is for PRBS.
Okay, so can you only do 16 bits if it is a explicitly defined pattern?
Yeah, explicitly defined pattern, maybe yes.
Okay, all right. Well, then okay. I'll add text saying it's only the lower bits.
But yeah, for PRBS, you need the whole seed. You cannot have just a part of the seed.
Okay, lower 16 bits. Okay, I'll add some bits on that. All right, moving on then. Let's see. Run /all bits. Run TX offset transmit pattern. How is that different from the other? Oh, it's set. Run. Okay, got you. Run the eye training, sure. Set phi TX termination value. Okay, I guess I'm not familiar enough with this. What does that mean?
So this is for the RX calibration. You need to terminate TX. There are two options. One is a 50 ohm termination, and another is a 150 ohm termination. So this is with respect to the VREF calibration on the RX side, that requires the transmitter to be terminated with a certain resistance value. So this basically tells the transmitter to set the termination value to the correct mode, and then the TX can do its calibration on its side.
So are these IDs implementation dependent then? They refer to specific voltages that are preset?
Correct. So when the TX calibration happens, the way this works is the TX calibration determines certain programming values that are required to terminate the link at 150 ohms versus 50 ohms. So it is supposed to store those values. And then the RX can request one of the two terminations when it is doing VREF calibration on its side. So once it requests a certain termination, I think the ID will probably need to say, what are we requesting? Are we requesting a 50 ohm termination or a 150 ohm termination? Paul, do you also have something similar in your implementation?
Yeah. We do.
Should we give it a specific values like term ID 0 is 50 and term ID, or should we just say, I don't know. Should we give it specific values here? I guess is for the two options.
Yeah, I mean, if we give it specific values, then maybe we keep it consistent for all implementations. I don't know if any other implementation requires anything other than 50 and 150. This comes from our 5 spec, so I don't know if the new 5 spec has anything additional defined.
Paul, do you have a opinion?
No, not really.
Maybe you can just put reserved. Maybe.
Let's say we want to, yeah, we can say reserved. We want to say any values are specifically, I mean, this is what, a 16-bit number, right? Do we want to say anything with the MSV set or something like that is implementation defined? So that people can, I don't know why you would do this. I don't know why you would have another value, but
Maybe, I don't know. I mean, if there is some vendor who built a file that is BOW compliant and some other
that's a
protocol.
good point. That's a good point. If people are uncompliant, then they're not going to be compliant to this. They can go pick a value. That's fine. All right, let's say, okay, so the lane, so this is, I think, obvious. I don't think we need any reason to, you don't need to set more than one bad line at a time, so it should be.
Yeah. I actually have a hard stop. I have to drop.
Okay.
But if there is anything, please feel free to assign a comment, and I will try to address that.
I think we're at a good stopping point anyway, and we can cover the rest of them next time. And then I'll have more text for you guys to review on trying to flesh those out. Thanks, guys.
Thank you so much, man. Bye-bye.
Thank you.
Yeah. Take care. Bye-bye.
Bye.